The quantities of distance, rate, and time are related such that the distance traveled is a product of the rate of travel and the time of travel. Of course, if we solve that formula for r, we obtain that r is the quotient of distance and time. Or if we solve the formula for time, we get that time is the quotient of distance and rate. So some ways in which this relationship can be used is exemplified in some of these examples here to follow. So first of all, that a cheetah's average running speed is 59 feet per second. How far will a cheetah travel after running 2 minutes? So you can see that given right here, we are given a rate of travel in feet per second there. And we also want to be able to determine that after this amount of time, how far the cheetah will travel. And so there is all three of these quantities of distance, rate, and time involved. So since we do know that this relationship between distance, rate, and time is d equals rt, and we're trying to figure out how far, then we're just determining that distance right there, which just means that if we take the known rate and the known time and find their product, we can find that distance traveled. So if we take that rate and we multiply it with the time, then what we end up getting is that 59 feet per second per 1 second is going to multiply with 2 minutes. Now, in order for that to really actually mathematically work out, what should happen is this amount of units for the time should really cancel each other out. But one's in seconds and one's in minutes. And in order for those times to cancel out, you have to have everything in the same units. So what I might do is I might take 2 minutes and change that into seconds then. And since 2 minutes is, of course, 120 seconds, then we're just going to multiply by 120 seconds, and then we'll get those seconds to cancel out, and then that will then lead us into having an answer that's only in feet, because that's the only unit we have left. So it's really just a matter of multiplying 59 with 120, and that ends up equaling 7,080, and that right there would indeed be the distance traveled by that cheetah in that 2 minutes time. Right below that, there's a train that travels between Boston and Washington, which is a distance of 457 miles. The trip takes 6.5 hours. What is the average speed of the train? And so you can see what we're trying to figure out is we're trying to figure out what the rate is. We are given that the distance is 457 and the time is 6.5. So we do know that if we take distance divided by time, that's going to give you the rate. So if you take 457 miles and then you divide that by 6.5 hours, then you can just divide that out and come up with the exact amount of speed that's traveling at. So it comes out to be kind of an interesting decimal, and so we'll just kind of approximate and say it's about 70.3. And then, of course, because we had miles and hours as our units, that would be in terms of a rate that's in miles per hour. And then finally here, a jet flies at an average speed of 540 miles per hour. How long will it take to fly from New York to Tokyo, which is a distance of 6760 miles? So given that distance right there, and then there's going to be a rate, then we can take 6760 miles, and we can divide that by 540 miles per hour, and then that should be able to give you the amount of time that it's going to be able to take. So if you do divide that out, comes out to be approximately about 12.52 or so, and that would of course be in hours since the rate there was specified to be in hours. Two airports, one located on the west coast in Los Angeles and the other on the east coast in New York City, are 3,000 miles apart from one another. The plane that departs from Los Angeles travels at a rate of 400 miles per hour, while the plane that departs from New York City travels at a rate of 350 miles per hour. The planes do leave at exactly the same time as one another. We want to be able to determine how much time it will take for the planes to meet one another. So for this problem, I think visualizing what's happening is going to be really helpful and also really kind of show us how simple this relationship actually is overall. So I'm going to draw a dot right here to represent the location of Los Angeles, and then a dot over here to represent where New York City is. We do know that the distance between Los Angeles and New York there is going to be a distance of 3,000 miles right there. So at exactly the same time, there are planes that leave from LA and New York and head toward one another. Now, the plane that does leave from Los Angeles travels at a little bit of faster rate of 400 miles per hour, while the one from New York travels at a rate of 350 miles per hour. So really what's helpful for this problem here is really just to think within 1 hour's time, really what's happening. And so since this plane right here is going at a rate of 400 miles per hour, then in the first hour of time, so after 1 hour of time, that plane's going to go that far and that plane's going to go that far. And by that far, I mean this plane's going to cover 400 miles and this plane's going to cover 350 miles, right? So really overall of the 3,000 mile distance between these planes, 750 miles has been covered thus far, right? And so there's all of this distance yet to be covered. And so what'll happen is then in the very next hour, this plane's going to cover the next 350 miles it's going to go in that hour, and this plane's going to cover the next 400 miles that goes in that hour. And so eventually, this entire 3,000 mile distance is going to be covered at the point where these planes meet. And so it's really just as simple as recognizing that, okay, well, every hour, 750 miles of this 3,000 mile distance is getting covered. So really, it's just as simple as recognizing that, okay, 750 miles is being covered every hour, and we want to multiply that by the number of hours, and then that's going to equal the number of miles of coverage, right? And specifically, we want to ensure that it reaches 3,000 miles of coverage. And so we're just taking 750 times h, the number of hours, equals 3,000, and just, I guess, solving that equation. If you do divide both sides of that by 750, you get a value of h that actually is just a nice natural number right there of 4, and it's going to be within hours. And that really truly does make sense, because in 4 hours time then this plane's going to go 400, 400, another 400, and then a final 400. So it's going to go 1,600 miles overall. And then of course the plane that departs from New York is going to go 350 miles 4 different times, and if you total that up, that's 1,400 miles of coverage. And so then when that first plane does go 1,600 and the other one goes 1,400, then total they've covered 3,000 miles at that particular point in time, and so that's going to be the exact point in time where those planes do meet.